continue more example. Again, I need to solve for x, and I have 3 examples here. You're gonna approach it differently. Look at the first one. This is base 5 and this is base 3. If you can make them the same base, you will try to do that. But in this case, I cannot make them the same base. So what I'm gonna do is I'm gonna try to bring the x down. I'm gonna take log both sides. You're gonna take log base 10, base e, or any base. But let's take log base e. So I'm gonna have ln 5 to the 2x minus 3 equal to ln 3 to the x plus 1. Next step, I'm going to use the power rule, bring the exponential up front. So I'm going to have 2x minus 3 ln 5 equal x plus 1 ln 3. Now the x is come to the base. Now I'm going to treat it like you would solve for linear. You're going to use distributive, combine like term, isolate the x, and solve for x. So I'm going to use distributive for both sides. So I would have 2x ln 5 minus 3 ln 5 equal to x ln 3 plus ln 3. Now I'm going to put all the x on the left hand side. Everything doesn't have x on the right hand side. So I have 2x ln 5 minus x ln 3 is equal to ln 3 plus 3 ln 5. I'm going to factor out the x on the left hand side. So I would have x times 2 ln 5 minus ln 3 equal ln 3 plus 3 ln 5. Now I'm going to divide both sides by this whole parenthesis to have x by itself. So I would have x equal ln 3 plus 3 ln 5 over 2 ln 5 minus ln 3. So at this point, you have to use calculator. So if you plug in the calculator, your answer should be 2.795. Alright, that's one technique. Another technique, look at this one. You have log of expression x squared minus x minus 5 equal to 0. So it's not on the exponential, but it's a log. So I'm going to rewrite it as exponential. So this is base 10. Alright, if I don't put anything, it's common base, which is base 10. So change to exponential is 10 to the 0 is equal to x squared minus x minus 5. 10 to the 0 is 1 is equal to x squared minus x minus 5. Now you just have to solve quadratic, set it equal to 0. So I'm going to have 0 equal x squared minus x minus 6. I think the best way maybe factor this. So if you can factor, you have to use other method. So this is x, 3 and 2 minus and plus. So x is going to be negative 2 and x is going to be 3. Right? Next one, another technique. So it's kind of like 2 terms. This one's only 1 term. This is you have 2 terms. So what I'm going to do, I'm going to condense this to 1 term. I'm going to use Quotient Rule. So I'm going to have ln 2x minus 3 over x plus 5 equal to 0. Alright, I have 2 terms there. I condense it to 1 term. Now I'm going to write it as exponential. Ln is log base e. Alright, this is log base e. So basically you're going to have e to the 0 equal to 2x minus 3 over x plus 5. E to the 0 is just 1, or 1 over 1 is equal to 2x minus 3 over x plus 5. I can cross multiply to get rid of fraction. So I'm going to have x plus 5 is equal to 2x minus 3. Now it's linear, right? I can solve. So let's see. I'm going to have x equal to 8. Alright, let's see more example. Let's look at an example of application of the exponential or log. The first one, how long will it take for Jenny investment of 5,000 to grow to 8,000 if the annual interest rate is 4% compound continuously? So this is the formula. A is the amount after a certain period of time. P naught is the principal. E is just E. R is the interest rate. You need to convert it to decimal. T here is time. So let's substitute all the number in the formula. So my A would be 8,000. My P is the principal, which is 5,000. E is E. R is the interest rate. You have to convert to decimal, which is 0.04, and then they're looking for time t. So first thing I'm going to do, I'm going to divide both sides by 5,000. Just to get rid of this 5,000. I think this is 1.6 is equal to E 0.04 t. The unknown here is the time and it's on the exponential. So I'm going to take log base E because I have E here. Alright, so I want to get rid of the E. So I'm going to have ln 1.6 ln E to the 0.04 t. Now on the right hand side, log base E of E to the 0.04 t is going to be 0.04 t, right? And then we have ln 1.6, so t would be ln 1.6 divided by 0.04. Then you need to use the the calculator. I think it's 11.75. years. So it takes about almost 12 years to increase your money from 5,000 to 8,000 if the interest rate is 4%. Alright. Now let's look at the next example. If a bond contains 98% of its original carbon-14, how old is the bond? That's the question. And the formula is carbon-14 has half-life after 5,730 years. So I'm going to use this formula here. So we don't know what is original. Alright, we don't know what is original. And we have E here. Think of R is a constant. Right, R is the constant 4%, and we don't know constant either. And the time, we know that the time is 5,730. The bond will be only half left. So whatever this amount is, you're gonna have half left. So that would be the equation. Because the original, and then you're gonna have half left after 5,730 years, and we don't know the K. Same idea, I'm gonna get rid of A naught. So I'm gonna divide both sides by A naught. So I'm gonna have 1/2 of E to the 5,730 K. We don't know what K is. K is on the exponential. I'm going to bring it down. I'm going to take log base E both sides. I'm going to rewrite this as decimal. You don't have to, but let's write it as decimal. 0.5 ln E to the 5,730 K. On the right hand side, because you have log base E of E to 5,730K, this is equal to 5,730K. Ln 0.5. From here, you can solve for K. So if we solve for K, my K would be, which is constant, negative 0.00012. That's my constant. Alright, my K. Now, I'm going to apply the formula again. We know half time is take 5,000, but we say the bone contains 98% of its original. So I'm going to have 0.98 because 98% of its original. So of its original, we don't know what it is, but it doesn't matter. Now E, now I have my K. My K is negative 0.00012, and we want to solve for time. How old is the bone? So we don't know the T. Alright, same idea. I'm gonna divide both sides by A0. So I have 0.98 is equal to E negative 0.0012 T. My unknown is the T. I have E here. I'm gonna take Ln both sides. Right, same idea. From here, I'm gonna have Ln 0.98 is equal to negative 0.00012 T. Now I can solve for T. So T will be Ln 0.98 divided by negative 0.0012. So T, let's see, we use the calculator, it's gonna be 168 year. So it takes 168 year for the bone to contain 98% of its original carbon 14. Alright, we finished chapter 4.